Hello, my name is Mark Hills. I'm an associate professor in the Department of Computer Science at East Carolina University in Greenville, North Carolina. My talk is Introducing DevOps Techniques in a Software Construction Class. I'd like to thank you for attending my talk, and let's go ahead and get started. So let me start by giving some context. We have a Master's of Science in Software Engineering program at ECU. It's a graduate program that we've offered here for more than 10 years. And our students can attend either on campus or online. And we have a mixture of students with different backgrounds that are in our program. So we have some that are continuing on in their studies immediately after earning a BS degree, a Bachelor's of Science degree in computer science. Some have professional experience, so they may or may not have an undergraduate degree in computer science, but they may have years of experience working in the field. Some may have a Bachelor's of Science or another undergraduate degree in another area, and they're switching careers. So what they want to do is they want to work as software engineers, but they've done their undergraduate studies in a different area. So one of our courses is our software construction course. Originally, we had different tracks in our graduate program, and this was part of the software development track. The focus of the course was really on scaling up development skills for larger software systems. So taking the types of skills you would learn in your introductory programming courses and that you would have applied in a lot of different homework assignments you would get over time in a standard undergraduate curriculum, and scaling those up so that you would be more aware of how to work with larger code bases, how to use concepts like abstraction, how to use tools for code comprehension or understanding, how to use good professional practices as you're working on code. So things like using IDEs, using good version control practices, build automation, unit testing, code coverage, things like this. So getting them used to working more like they would work as a professional developer, where they're looking at bigger systems than they can fit in their head all at one time. Originally, there was no focus on the cloud in this at all. So what we decided to do, though, is we thought we want to start to work on cloud concepts in the course, especially related to software development and DevOps. These are becoming more common in industry. These would be important for their careers. And so it'd be good if they're learning good professional practices to start to encounter these. Our first attempt at doing this was somewhat lightweight, where we said, well, there's a lot of existing vendor documentation, a lot of good getting started material, examples, online readings. And so what we'll do is we'll leverage that. Most of what we'll do in our first attempt at this to introduce these concepts into the class is structure different activities based directly around the vendor documentation. The activities weren't graded. It was really just participation. The goal wasn't for students to get these completely correct, but really to get them to try things, to try to develop their interest in that and give them some exposure to it. This didn't go so well, right? I'll be completely honest with our first attempt. So we encountered several problems in this attempt. Sometimes, and this was actually a minor issue, sometimes the technologies change faster than the docs. Usually the docs stay fairly up to date. It would be more an issue if we had, as the instructors, looked at the documentation and then something changed during the semester. A bigger issue, many of the docs are written for professionals with richer backgrounds. So they assume a lot of background knowledge that our students may not have. Going along with this, if you're looking at the documentation and you are trying to take the material in that documentation and apply it to your own situation, it's important to be able to differentiate the fundamentals. Right? What are the important commands, the important concepts, the things I need to do with my own system versus the examples, right? What things am I typing in just because this applies to the example, but it wouldn't apply to what I'm doing? And so what you would see is that students would use commands without necessarily knowing what parts of the command needed to stay the same or what parts of the command would change to adapt it to their circumstance. And then if the students got lost going through this, they wouldn't know how to get back on track because they wouldn't necessarily know where they went off track. And so they wouldn't know how far back to go to recover. So our second attempt at this, we learned from this. We said, okay, we're going to start from scratch. We have 4 different activities, one on continuous integration, one on Docker, one on Kubernetes, and one on continuous delivery. And we're going to start creating more of our own material for this, our own examples, And we're going to look beyond what we already saw for more options for materials. So we have access to LinkedIn Learning, for instance. We'll use videos from that. We can use Quick Labs. We can use other things. We're still looking at what to add in, but for now, we mainly use LinkedIn Learning. Documentation we created ourselves, vendor documentation, and then other materials, including the code examples and such. We have ready-made starters for each step. So if you couldn't complete the prior step, then you can start with what we provide. And again, it's staying the same because we think this worked well before. You get credit for participation, but this isn't formally graded. So this is lower stress for the students. They can really try to do it to learn it without worrying about the impact this will have on their grade. Okay, so here's the overview of the entire activity. We have a very simple web application we've called the Helloizer, and that is a Java-based RESTful API. It's just a web service that if you contact the endpoint that it provides, it will say hello and give you a little bit more information. You can provide your name, and it will actually say hello to you, and it also provides a unique ID and a timestamp. We are keeping track of all the code on GitHub using Travis CI for continuous integration. We are creating Docker images. Those Docker images will be used to create locally running containers. We will store them on Docker Hub. We will also mirror GitHub to Google Cloud Repository. We will use Google Cloud Build as another continuous integration and build service. We will store images on Google Container Registry, and we will use Google's Kubernetes engine cluster in order to actually create a Kubernetes cluster and run those containers based on those Docker images. So those are all the moving parts that we would see once everything is done. But what we have then is we have these 4 activities that we have the students do. The first activity focuses on continuous integration. The overall goal of this is that students enable continuous integration in their projects, or in this case, in the Helloizer project, and they actually see it in action. Right, so what they do is they take the starter code, they create their own fork of that, they enable integration. The build currently fails because of an error we inserted into that. So when they push the code initially, we have them make a minor change, push it, they see that it breaks, they see they get information on where that breakage occurs. They can then fix it, they can push the code back to GitHub, and they can see that it passes this time, right? Looking at Travis CI and the different messages they get, and they can even add the little badge into their repository that shows that the build is passing. So fairly straightforward exercise. There isn't a lot going on. There aren't a lot of different steps they have to take. They don't really have to do much with the code. It's not a web development class, so we don't assume they know something like Java Spring. But the things they need to do in the code are fairly easy to find, and we describe them and we put comments in the code so they can figure out fairly quickly where they need to go. Activity 2 uses Docker, and the goal here is that students learn the basics of Docker, including build automation to create images. So they need to know how to create images, how to use those images to run containers, and how to automate creating a new version of the image when they make changes to the code. So they have to create a Docker file, test the image, automate building the image, and then they also push the results to Docker Hub and to GitHub with the code. Activity 3 uses Kubernetes. And so what the overall goal of this activity is students learn how to deploy a Docker image to a Kubernetes cluster. And so here we still have these pieces, right, with the Docker images. They can run them locally, but they also then need to send the image to the Google Container Registry and use that to create the Kubernetes cluster that actually is running the Helloizer web service. So they also go through some additional steps here. They get credit for Google Cloud Platform. They need to set up a project. They need to push the image up to there. They work with the SDK, so they need to get a little more comfortable with that and getting an API key. They create the cluster, deploy the image, and make it available so they can actually hit it with their browser. And then activity 4, continuous delivery. The overall goal of this activity, of this final one, is the students put the prior steps together to deploy changes to their cluster so that the changes are visible right away. And we call this continuous delivery because this is kind of the development side. We're not thinking about this being production where it would just automatically be visible to the world. So this is their development environment that they have set up, including cloud support for that, because that's their development target. And so here we use Google Source Repository. They mirror their GitHub repository there. So when they make changes to GitHub, those changes automatically go to the cloud repository. We use Cloud Build to grab those changes and to create the new Docker image that gets put into the container registry and then updates the Kubernetes cluster. And so at first the update is manual. They have to trigger it and see that it works. At the end of this, it's automated. So then when they check in their changes to GitHub, their changes are automatically deployed out to their Kubernetes engine cluster. Okay, so in summary, right, by the end of this, they have this working end to end where if they change something locally, push those changes to their GitHub repo, then that's going to trigger the rest of these steps. So they'll create a new Docker image, they'll update Kubernetes, they can change the API output then and quickly see the deployed changes. So what are some lessons learned from this work that we've done? One thing that we noticed is that command line skills are important, and I would say maybe even becoming more important because the way that many of these systems are accessed is using the command line. At least that's the most direct way to access them quite often, and especially for scripting things. But those are often missing or sort of weak skills in our students. They quite often come in and they haven't used the command line much. And so just getting over that hurdle can make these types of activities challenging for them. They're just not that familiar with, say, moving around within their directory structure, running other commands. And so when you start having them type commands in, that can be a little daunting for them. Vendor documentation is important, but it's often missing context the students need. That's something that I mentioned earlier in our first attempt, right? Some of the problems we found, or sometimes it just isn't clear what pieces of the documentation are just for that example, and which pieces you would say change to update to your example, which pieces always need to be there, right? If you were a professional and you were more familiar with it, you would know that this part of the command is there because of the example and you would change that for your own use, while this other part of the command is just that's the command you need to use. But sometimes students just have trouble understanding that because they aren't as familiar with these types of systems. They haven't seen these as often, so they haven't built up that mental model of what these things typically look like. Number three, smaller assignments are easier to follow. If we break things up into smaller pieces, and we might even break these up further, then it's just easier for students to stay on course. It's not as, there aren't as many things they need to do, and so if they get lost, it's easier to get back on track. They will get stuck. It's important to be willing to work with your students on this. Right, there are parts here that are just really tricky, and so even with the best attempt on their part, they may get stuck on something. And so it's also important to practice these yourself and to understand them really well, because if they run a command that's incorrect, it could be they're doing something that you just haven't predicted they would do. And also just be patient with yourself as well, right? There's a lot to learn in here, and it's hard to keep up with. And so it's important to stay on top of it if you're using these types of activities. But things change all the time, and so just have patience with yourself as well. So also, student impressions on these assignments. Student reaction was generally quite positive. The first two of these assignments, these activities, they generally had few problems with, right? That was the continuous integration and the Docker assignments. But the other two, they were more likely to struggle with. Especially the third one and the end of the fourth one. Basically, anything dealing with Kubernetes tended to be challenging for them. One part of our future work we'd like to do is extend these to improve them, get feedback from people, maybe again break them into smaller pieces, add more material, add more structure to this so that the students can understand them better, make them easier to share. Another part is to evaluate these more rigorously. This is essentially what I consider a promising experience report. We're describing this set of activities we did. We describe the reaction, but we haven't really empirically evaluated this to see if we see, say, an improvement in their understanding of these if they do these activities. So we would like to do that in the future. At this point, please take advantage of the facilities that we have at the conference with Slack and the other technologies to ask questions. I'm happy to discuss the work I'm talking about here further. Thank you.